Hello students, I hope you are all doing well. I welcome all of you for today's class. In the last class, we played few games with numbers. In fact, we also solved few puzzles based on numbers. So, in this class, we will learn more about the divisibility of numbers. Students, in our previous classes, we had seen how to check the divisibility of the numbers by 10, 5, 2, 3, 6, 4, 8, 9 and 11. Students, those tests were very easy, but then we did not answer the question why they were true. Now, we will answer why those tests worked for checking the divisibility. Firstly, let us look at divisibility by 10. Students, indeed this is easiest of all. Look at some of the multiples of 10. 10, 20, 30, 40, 50, 60 and so on. And observe some of the non-multiples of 10. 21, 45, 52, 67, 82, 91. Students, from the above list, it is clear that whenever the units digit is 0, it is a multiple of 10, and when it is a unit digit is not a 0, it is not a multiple of 10. So, we get a test of divisibility by 10, but then let us see how it works. Let us take the number CBA, which is a short form for 100C plus 10B plus A. Here A is the ones digit, B is the tens digit and C is the hundreds digit and so on. Students, make a note that the dots are there to say that there may be more digits to the left of C. Since 10, 100 and so on are divisible by 10, clearly 10B, 100C and so on are also divisible by 10. So, as far as A is concerned, A is divisible by 10 if the number is divisible by 10, and this is possible only when A is equal to 0. And hence, a number is divisible by 10 only when its ones digit is 0. So, now let us explore more about divisibility by 5. Students, as we did earlier, look at the multiples of 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50 and so on. It is clear that the ones digits are alternatively 5 and 0 and no other number ever appears in this list. So, we get the test of divisibility by 5, that is, if the ones digit of a number is 0 or 5, then it is divisible by 5. Students, let us try to explain this rule. Any number CBA can be written as 100 times C plus 10B plus A. Since 10, 100 are divisible by 10, so are 10B, 100C and so on, which is in turn are divisible by 5 because 10 can be written as 2 times 5. And as far as number A is concerned, it must be divisible by 5 if the number is divisible by 5. So, A has to be either 0 or 5. Students, let us solve a problem now. Look at the problem. The problem says, if the division n divided by 5 leaves a remainder of 1, what might be the ones digit of n? Students, observe that in this division, the ones digit when divided by 5 must leave the remainder 1. So, by the test of divisibility by 5, we have, if the ones digit of a number is 0 or 5, then it is divisible by 5. That means, whenever the ones digit of a number is 0 or 5, upon division by 5, it leaves remainder 0. So, to leave a remainder of 1, the ones digit of a number must be 0 plus 1 is equal to 1 or 5 plus 1 is equal to 6. Hence, the ones digit of the number n is either 1 or 6. Students, let us study more about divisibility by 2. So, as earlier, look at the multiples of 2. 2, 4, 6, 8, 10, 12, 14 and so on. And look at some of the non-multiples of 2. 1, 3, 5, 7, 9, 11, 13, 15 and so on. Students, observe that in all the multiples of 2, the ones digit is either 0, 2, 4, 6 or 8, and hence we get the test of divisibility by 2. That is, if the ones digit of a number is 0, 2, 4, 6 or 8, then the number is divisible by 2. Students, let's try to explain this rule. Any number CBA can be written as 100C plus 10B plus A. Since 10, 100 are divisible by 10, so are 10B, 100C and so on, which in turn are divisible by 2 because 10 is equal to 5 times 2. And as far as number A is concerned, it must be divisible by 2 if the given number is divisible by 2. So, this is possible only when A is equal to 0, 2, 4, 6 or 8. Students, let's solve another problem now. Look at the problem. If the division n divided by 5 leaves a remainder of 4 and the division n divided by 2 leaves a remainder of 1, what might be the ones digit of n? Students, observe that in this division the ones digit when divided by 5 must leave the remainder 4 and the ones digit when divided by 2 must leave the remainder 1. So, by the test of divisibility by 5, we have, if the ones digit of a number is 0 or 5, then it is divisible by 5. That means, whenever the ones digit of a number is 0 or 5, upon division by 5, it leaves the remainder 0. So, to leave a remainder of 4, the ones digit of a number must be 0 plus 4 is equal to 4 or 5 plus 4 is equal to 9. We know that by the test of divisibility by 2, if the ones digit of a number is 0, 2, 4, 6 or 8, then it is divisible by 2. That means, whenever the ones digit of a number is 0, 2, 4, 6 or 8, upon division by 2, it leaves a remainder 0. So, to leave a remainder of 1, the ones digit of a number must be 0 plus 1 is equal to 1, 2 plus 1 is equal to 3, 4 plus 1 is equal to 5, 6 plus 1 is equal to 7 or 8 plus 1 is equal to 9. We need the digit which satisfy both these divisions and hence look for common possibilities. So, the common possibilities of the digit of n is 9, because when divided by 5, 9 leaves the remainder 4 and when divided by 2, it leaves the remainder 1. Students, now let us study about the divisibility by 9 and 3. Before that, if we look at the 3 tests of divisibility which we have done till now, that is divisibility by 10, 5 and 2, we observe that we only use the ones digit of a given number and do not bother about the rest of the numbers. In fact, the numbers 10, 5 and 2 are the divisors of 10, which is a key number in our place value. But surprisingly, for checking the divisibility by 9, this will not work. Let us take some number 2574. It can be expanded as 2 times 1000 plus 5 times 100 plus 7 times 10 plus 4, which is equal to 2 times 1000 can be written as 999 plus 1. So, plus 5 times 100 can be written as 99 plus 1 plus 7 times 10 can be written as 9 plus 1 plus 4. So, 2 times 999 we write the same, plus 2 times 1 we get 2, which we will write at the end, plus 5 times 99 we write the same, and so we write 5 times 1 is equal to 5 at the end, and 7 times 9 we write at the initial stage, and 7 times 1 we write at the end. So we get 2 times 999 plus 5 times 99 plus 7 times 9 plus 2 plus 5 plus 7 plus 4. Clearly 9, 99, 999 are divisible by 9 or 3, and so 2574 is divisible by 9 or 3 if the sum 2 plus 5 plus 7 plus 4 is divisible by 9 or 3. We see that 2 plus 5 plus 7 plus 4 is equal to 18 is divisible by 9 and also by 3. Therefore, the number 2574 is divisible by both 9 and 3. Students, let's check what happens if we consider the number 2577. 2577 can be written as 2 times 999 plus 5 times 99 plus 7 times 9 plus 2 plus 5 plus 7 plus 7. This we have got by doing the steps as earlier. Since 2 plus 5 plus 7 plus 7 is equal to 21, it is not divisible by 9, but it is divisible by 3. Therefore, the number 2577 is not divisible by 9, however, it is divisible by 3. Students, hence we get a test of divisibility by 9 or 3 as a number n is divisible by 9 if the sum of its digits is divisible by 9. Otherwise, it is not divisible by 9. A number n is divisible by 3 if the sum of its digits is divisible by 9. Otherwise, it is not divisible by 3. Students, let's try to explain this test of divisibility by 9 or 3. If the number is CBA, then 100C plus 10B plus A can be written as 99C plus 9B plus A plus B plus C. So, that is equal to 9 times 11C plus B plus A plus B plus C. Since 9 times 11C plus B is divisible by 3 and 9, hence the divisibility by 9 or 3 is possible if A plus B plus C is divisible by 9 or 3. Students, let us solve some problems based on this. Students, in the given problem, check the divisibility of the number by 9. 9 crore 12 lakh 54,843 by 9. Let us try to use the test of divisibility by 9. That is, a number n is divisible by 9 if the sum of its digits is divisible by 9. So, let us find the sum of digits of the given number. 9 plus 1 plus 2 plus 5 plus 4 plus 8 plus 4 plus 3, that is equal to 36, and this number is divisible by 9. Let us double check. The number 9 crore 12 lakh 54,843 divisible by 9, we get 1 crore 1 lakh 39,427, and hence the division is exact. Students, now let's move on to problem number 2. Check the divisibility of 1,52,877 by 9 and 3. Students, let us find the sum of the digits in the given number. The sum of the digits in the given number is given by 1 plus 5 plus 2 plus 8 plus 7 plus 7, that is equal to 30. This number is not divisible by 9, but it is divisible by 3. So, by the test of divisibility by 9 and 3, we conclude that 1,52,877 is not divisible by 9, but divisible by 3. Students, let's look at another problem. If 31Z5 is a multiple of 3, where Z is a digit what might be the values of z? Students, it is given that 31z5 is a multiple of 3. That means it is divisible by 3 and hence the sum of its digits 3 plus 1 plus z plus 5 should be divisible by 3. This implies 9 plus z is divisible by 3, which means 9 plus z is one of these numbers 0, 3, 6, 9, 12, 15, 18 and so on. Make a note that z is a digit, it is a number between 0 and 9. So, this means that z can take the values 0, 3, 6 or 9. Students, let us look at another problem. If the 3-digit number 24x is divisible by 9, what is the value of x? Students, it is given that 24x is divisible by 9. Therefore, the sum of its digits, that is 2 plus 4 plus x should be divisible by 9. That is 6 plus x should be divisible by 9. This is possible when 6 plus x is equal to 9 or 18 and so on. But make a note that here x is a number between 0 and 9. So, this is possible whenever 6 plus x is equal to 9, that is x is equal to 3. Students, let us look at a final problem. If 2, 1, y, 5 is a multiple of 9 where y is a digit, what is the value of y? Students, it is given that 2, 1, y, 5 is a multiple of 9, that means it is divisible by 9 and hence the sum of its digits 2 plus 1 plus y plus 5 should be divisible by 9, which implies 8 plus y is divisible by 9. That means 8 plus y is one of the numbers 0, 9, 18, 27, 36, 45 and so on. Make a note that since y is a digit, it is a number between 0 and 9. So, this means that y can take the value 1. Students, here we end the class. Before we wind up, let us recollect what all things we have learned today. In this class, we learnt the different tests of divisibility such as divisibility by 10, divisibility by 5, divisibility by 2 and finally divisibility by 9 and 3. In fact, we have also explained why these tests work. So, finally, we have also solved problems on these tests. Hope you had enjoyed the class. Have a good day. Thank you.